Good morning, or good afternoon. There is an abundance of primary solar energy in the tropical ocean zones, and as we've heard from other speakers, this is accumulating at a dangerous level. Natural carbon emission reduction ceases to harness that primary solar energy to capture, liquefy, and geologically store the natural emissions of CO2 that emerge from the oceans. That's in the short to medium term. In the longer term, because we hope to be able to harness that primary energy to convert that captured carbon into new generations of synthetic hydrocarbon fuels. So it makes sense to go where the carbon is emitting, and it makes sense to use that abundance of primary solar energy. As part of the technology, we're also planning to introduce a mechanism, a novel mechanism for delivering adaptation funding. We all know that climate change is likely to have some severe effects on the developing states, mostly in these tropical zones, and there is a mechanism by which we can translate that carbon capture into adaptation funding. Decoupling CO2 emission reduction from energy generations does present some attractive options for governments, for academics and scientists, and it has an equal effect on climate change mitigation. It probably doesn't need me to tell many people in this audience that the ocean is the largest store of carbon on the planet. It's also the largest natural systematic emitter of CO2 into the atmosphere, and natural carbon emission reduction seeks to capture that carbon before it emits into the atmosphere, and it will have the same effect on climate mitigation as capturing the anthropogenic emissions. We believe it would be not only substantially cheaper, but also is able to scale up much more quickly and to a much greater extent than conventional carbon capture. This is just an illustration of the carbon cycle that exists. It's fairly simple and probably well known to most of this audience that the cool waters of high latitudes absorb carbon. The ocean conveyor carries that carbon back down towards the equatorial regions, where it naturally upwells, and as it upwells into the tropical zones, it gives off that carbon load in the form of carbon dioxide into the atmosphere, which moves back up towards the high latitude. So it's a continuing cycle that has been in balance, but as a result of anthropogenic input, that balance has been lost. The benefits of NCR is an innovative geoengineering technology, and I'm pleased to hear Tim's remarks. It's highly scalable and extremely rapid to deploy globally because it's decoupled from the anthropogenic sources. It doesn't have to wait for economic or political decisions. It's controllable and predictable as a CO2 removal process as opposed to the solar reflection processes. And it complies fully with the Oxford Principles on Geoengineering, which Tim has talked about and which we support absolutely. There are global economic advantages to the NCER process. We believe it's the lowest possible marginal cost of CO2 capture and storage because it uses primary solar energy to power the system rather than the fossil fuel energy that's used in conventional carbon capture. It can couple with that the innovative payments mechanism for a green climate fund. That's $100 billion of your money that's going from the developed countries to the developing countries. We can combine that in one process, resulting in a single payment from you as a consumer, you as a taxpayer, for both climate mitigation and the supply of adaptation funding. Finally, there are also, and I'm pleased to see the next speaker here, the benefits to the UK economy as a whole. It's an innovative carbon capture technology, for opportunity for the UK to take a global lead in this industrial initiative. The low-cost offsets procured from UK operating companies that can operate this technology in tropical zones can provide a much lower cost offset at a much reduced price so that the UK can meet its target emission reduction targets. And as I mentioned earlier, looking forward to the future, it's a foundation for future synthetic hydrocarbon industry for carbon capture and conversion. Thank you very much.